Okay, so here comes lesson 6-2. Now 6-2 can eat you alive if you let it do it to you. Okay, so make sure you're focused up on this lesson here because we're going to be looking at a couple of things here that are very, very critical um, steps that can lead you to some correct answers. There's definitely one way that you can go on these problems that can make the problems a lot harder than they really need to be. Okay, but let's just focus on some very, very basic stuff here first. Okay, and the very, very basic stuff here that is true about products of radicals is the only way you can actually multiply radicals together is if they have the same index number. That's pretty much what's going on right here. Okay, the index n must be the same. So what you're looking at right down here is several true-false problems right here. So true or false, if you look at this one on the left, if I have a cube root of 4 times a cube root of 6, is that actually equal to the fourth root of 24? Well, the correct answer there would be false, right? That's not true because we're going back here. The indexes have to be the same. In fact, what would be wrong about this and how we could correct this mistake is true. The indexes are the same. They're both 3's, so we could easily fix this problem by saying that that would be the cube root of 24. That would actually be true. Cube root of 4 times the cube root of 6 would be the cube root of 24. How about the next one? The cube root of 36 could be broken apart into the cube root of 4 times the cube root of 9. What do you think of that? Is that true or is that false? You got it. That would definitely be true, right? Because since 36 is 4 times 9, we can break it apart into 2 cube roots. How about the last one over there? The cube root of 3 times, I'm sorry, the fourth root of 3 times the fourth root of 8. Is that the same as the fourth root of 24? Yes, sir, it is. Okay, so when you look at these problems right down here, is it possible for us to multiply the cube root of 6 times the square root of 2? Absolutely not. We cannot. Reason why is because a square root always assume that there is a 2 right there, even though they don't put 2's right there. Square roots, they have a 2 right there. And see how we have an index of a 3 and an index of a 2? Because the indices, I think that's a grammar mistake there by the math textbooks, the indexes are different, the property does not apply. If you look at this one right here, look at B. Cube root of negative 4 times the cube root of 2. Yep, you certainly can multiply those two together. And what you do there is you can multiply the negative 4 times the 2, you get the cube root of negative 8. See what they did there? They simplified it afterwards. So always look to simplify after you do the product as well. So the cube root of negative 8 actually would be negative 2. So we have two examples right here. Can you simplify these? Okay, we'll go ahead and pause the video, see if you can do it. So what do you think? Could you have simplified the fourth root of 7 times the fifth root of 7? Absolutely not. The index is not the same, so you can't do anything with it, so that's actually simplified. And we've just explained why we can't simplify it, because the indices are different. How about the other one, the fifth root of negative 5 times the fifth root of negative 2? We can simplify it because the indices are the same, so then we can multiply the negative 5 and the negative 2 together. We end up with the fifth root of fifth root of positive 10, which we actually can't simplify because there is no integer that when you multiply by itself 5 times you get 10. Cannot do it. Do not confuse this with addition. We're dealing with multiplication here. Okay, so there's problem number 1.